everybody, we will be talking about deploying Kubernetes applications with GitHub Actions. Now, before we get started today, a little introduction on myself. I'm Avin Indrasoma, a software engineering undergraduate from Colombo, Sri Lanka. I'm currently working on building technical communities around the region, and I'm also a part of GitHub's Campus Experts program. And I've had the chance to be a part of a few local communities, including the team behind KCD Sri Lanka. Now, if you want to find out more about me or get in touch, you can use the link on screen, which is avin.info. Now, before we get started, since this will be a lightning talk, it will be concept based. However, I will be linking some additional resources at the end of the talk, including a tutorial for a guided technical walkthrough of the steps that we are going to be discussing in case you need additional help or clarification when replicating the steps in your machine. Now, to understand the basis of the topic today, we must first understand the term CI/CD. I'm sure that this is a term that most of you folks joining us today are aware of, but if you're not, it stands for or is short for continuous integration and continuous deployment. Now, the latter part of the term CD, short for continuous deployment, is mainly what we are focusing on today. Now, if you don't know or if you're not aware of what continuous deployment is, continuous deployments rather is simply a strategy or a practice where changes and updates to a code are automatically released to a production environment. Now, in order to create a continuous deployment for Kubernetes, the tool that we're going to use here today is, yep, you guessed it, GitHub Actions. Now, GitHub Actions, before we get Kubernetes involved with it, we'll try to understand very simply what GitHub Actions are and how they work. Now, GitHub Action workflows are written in YAML, written as YAML files rather, and they're stored in the .github/workflows directory of your working repository. Now, on screen, the code snippet on screen shows the three most basic components of a GitHub action, which is the name, the on condition, which necessarily dictates when the GitHub action is run or triggered, and the jobs, which basically state what is to be run when the action is triggered. Now, but before we get Kubernetes involved with our GitHub actions, there's a very important there's a very important step rather that comes with continuous deployments. It becomes very important to have automated tests associated with continuous deployments to ensure that we don't have bugs deploying into our production environment. Now, what we usually do is manual testing, but this will necessarily be the purpose of having a continuous deployment environment. So we use automated testing, and what we do is we bind the testing parameters to the GitHub action itself. Now, automated testing and associated tools change based on the tech stack of your application, and automated testing will sometimes, or most of the times rather, require you to start database containers, install dependencies, and run migrations. Now, in this specific example of the code snippet that I've shown on screen, I've set up a Node.js environment and used npm for package management and to install the dependencies. Finally, it runs database migrations and even the tests towards the latter part of the snippet through npm. Now, once again, just a reminder that you can edit and modify the test to fit the requirements of your project, and this is just an example. So now that we have gotten the tests out of the way and we have ensured that the code is ready for a production environment, what's next? And that is building the Docker image. Now, before we look into how we're going to build the Docker image, something that I specifically wanted to touch with this talk is a tool that we can use to store the Docker image. Now, most people generally use Docker Hub, but there is a much more cost-effective and efficient alternative to Docker Hub, and that is GitHub Container Registry. In short, we call it GHCR. Now, apart from being far more cost-effective than Docker Hub, there's a very special advantage of this that we can use here today for what we are doing, and that is the token generation. So for each run, there will be a completely automatic process that creates a token when using GitHub Container Registry, so you don't have to worry about that when building these workflows. Now, once we have gotten GitHub Container Registry set up, we'll be using the Docker build push action. Now, this is a pre-built action, the Docker's build push action, which builds the images, and there's an additional tool that we are using in this step here, which is BuildX. Now, BuildX is also installed and set up in the code snippet that's shown on screen now. And once that's done, we have also included the GHCR credentials to log in. And at the end of the workflow, keep in mind that the image here is tagged as the latest image possible. Now, the tag towards the very last part of the snippet, what it basically does is that it labels to the system that this image is the latest image. Now that we have successfully built the image and pushed it to the container registry, the next step is deploying the image to Kubernetes or deploying to the cluster. But it's important to note here that GitHub Actions require authentication so that it can trigger deployments in the Kubernetes cluster. And similarly, the Kubernetes cluster requires access to the image from the container registry. Now, these credentials can be stored as a secret, which can be referred by the pod via the image pull secrets field. I will be linking a resource for detailed and in-depth instructions of the image pull secrets field at the end of the talk, as I do not have time to get into detailed explanations of that specific field. Now, once we have the authentication processes out of the way, like I said, we have to do the final and the most important step, which is deploying our freshly built image to our cluster. Now, Azure has a pre-built action called Azure K8, and this will deploy all the manifests. So now let me explain how this works. So what it basically does is this action takes a list of our image tags that we've created, and it substitutes them with references to those images in the manifest files before applying the manifest into the cluster. So before the manifest goes into the cluster, the action takes a list of our images and it substitutes the references to those images in the manifest file. So that's basically what's done through the code snippet shown on screen. But we have to make sure that something that I've not done here, that we have to ensure when using this in actual production environments, is to make sure that this deployment job that we just created is triggered only for specific branches based on your requirement. So whatever branch that has a deployment environment associated with it, you can limit this action to those branches specifically. Now, that is basically a very fast explanation of how we can ensure that your Kubernetes application is integrated, tested, and deployed smoothly and automatically, all thanks to GitHub Actions. If you have any questions, you can contact me on the email, or you can access a set of resources at the end of the slide deck using a QR code. But before I wrap up, I have one last resource to share with you folks, and if this is especially useful if you're a student getting started with development or in your Kubernetes journey. So you can use what's called the GitHub Student Developer Pack. And what this Student Developer Pack does is it helps you get your hands on a series of resources, including application licenses, education resources, tutorials, and much more. I've added a QR code to an instant verification link, which you can use to verify that you're a student and get your hands on these benefits today. That's it for my talk. I hope you all understood the basics of deploying a Kubernetes application with GitHub Actions. You can find all the linked resources by scanning the QR code. Thank you.